All right, today we're going to continue talking about graphical transformations. Combining transformations. Transformations may be performed in succession one after another. If the transformations include stretches, shrinks, or reflections, the order in which the transformations are performed may make a difference. In those cases, be sure to pay particular attention to order. Excuse me. Whatever's happening on the inside of parentheses with x, you do in the opposite of what you read. In other words, instead of doing parentheses, exponents, multiply, divide, add, subtract, you go in Asmodep order. Okay, you do adding and subtracting first, then multiplying, dividing. We won't have exponents or parentheses, but if it's outside of parentheses, or the function, all right, then you're doing your operations on y, and you do what you read in PEMDAS order. Okay, just remember, it's with your crazy x, it's inside with your crazy x, you have to do opposite. Nothing makes sense with your crazy x. Alright, so it says name the mother function, describe the translation, and then sketch a graph of the function. Alright, well the mother function, I see the square, so my mother function is going to be y equals x squared, which is the parabola. Okay, my transformations. This is happening to y, and this is happening to y. And this is happening to x. It doesn't matter if you do your x moves first or your y moves first. If I do my x moves first, that means I'm going to go left 2. Now, instead of just sketching this, to me it's easier just to make a list of ordered pairs. Your mother function passes through, you can use any points, but I always use these 3 points. It passes through -1, 1, 0, 0, and 1, 1. And you can get any points. I just plug in, pick x's. If I plug in -1, squared is +1. Plug in 0, I get 0. Plug in 1, squared, I get 1. Those are mother function points. So what this says is whatever you're going to do to these ordered pairs, you have to do them in a certain order. If I do my x moves first, then what that means is I'm going to, we know, do the opposite. So this, instead of adding 2 to the x's, I'm going to subtract 2 to the x's. That gives me -3, 1, -2, 0, -1, 1. That's done. So now, I should have done that in blue, sorry. So now I need to do my y moves. Well, when you have more than one, order matters. This is multiplication, this is subtraction. For y, you do PEMDAS order, so I'm multiplying first. So I'm going to multiply my y's by -4. That gives me -3, -4, -2, 0, -1, -4. That's done. But I still need to do the -3. Again, it's happening to y, so you don't do the opposite. So I'm going to -3 to all of my y's. I get -3, -7, -2, -3, -1, -7. So if I plot those points, -3, -7, -2, -3, and -1, -7, you get this. Okay, oh crap, we forgot to describe the translation. Alright, so let's do that. My function was -4, x plus 2 squared minus 3. Alright, we got a whole bunch of stuff. This negative is going to reflect over x. You can see it turned upside down. The 4 is outside, so it's vertical, and that's going to be a stretch bigger than 1. The 2 is on the inside, that's going to be a horizontal, and that's going to go left 2. And then the -3 on the outside, that's going to be a vertical shift down 3. Okay? So there's my mother function, there's my description, and then there's my sketch of the graph. Alright, and if you can see under all my writing, mine's pretty darn close. No, mine is not. Oh, it's -1, -7. Sorry, I made that too wide. Yeah, see, it's good to check. Alright, so if we do this one, again, mother function is y equals x squared. which we know uses the ordered pairs -1, 1, 0, 0, 1, 1. I got to do two things to my x, okay? I've got multiplication by 3, and I've got subtraction by 7. When you're doing things to x, you do them in Asmodep order. So I've got to do the -7 first, which means I got to do the opposite. So I'm going to add 7. I get 6, 1, 7, 0, 8, 1. And then I have to, they want me to multiply by 3, which means I'm going to divide by 3, because we do the opposite. So divide by 3, divide by 3, divide by 3. I get 2, 1. I get 2.6 repeating. 2.3 repeating. Oops, darn it. Oh, there we go. 2.3 repeating, 0. And this would be 2.6 repeating, 1. So I've done the x moves. The only y move that I have, give me just a second, arrows went away. See if I can't get them back. There we go. Alright, so we've done our x moves. The only y move to do is adding 5. It's going to go up 5, so I add 5 to the y's. And I didn't really want you to see that picture yet. I get 2, 6. I get 2.3 repeating 5, and I get 2.6 repeating 6. Alright, so if I plot those points, alright, I'm going to have 2, 6, 2.3, 5, and 2.6. This is all really back at 6. It's really tiny. Okay. Alright, so if we look at the graph, sure enough, there, I mean, if this kept going, this would actually cross it. Okay. So I'm pretty close. Describe the transformations. Now here's where it's going to get a little difficult. Not difficult, but you can't, what people would want to say is that you would go right 7 and shrink by 3. You actually don't go right 7. Notice I didn't go to the right 7. This isn't, this vertex is not 7 units that way. And the reason why is because of that 3. You have to factor out that 3. And if I factor out 3, I get x minus, you can leave it 7/3, or that's 2.3 repeating, squared plus 5. So what that means is, this 3 is inside parentheses, so that's horizontal. You'd think stretch because that's big, but it's actually going to be a shrink of, flip it over, 1/3. And look, horizontally, they shrunk this thing, which means it's going to be much thinner, and mine is. Okay, this is going to say a -2.3 means 2.3 units to the right. And notice that that's about what I went, 2.3 something. I didn't go 7. And that's why. If you don't factor this out, you won't get the right. It doesn't affect the graphing as long as you're careful. But you won't say the transformation right if you don't factor out that number touching x. And then, of course, the 5 on the end is going to move it up 5. Okay? Alright, try to describe the translation. Hit pause, come back when you're ready. And good. Here is going to be left 1, because it's with your crazy x's backwards, and here's going to be down 3. And sure enough, there's mother, left 1, down 3, and there's my new one. Okay, try this one, hit pause, come back when you're ready. And this negative on the outside, that's your reflect over x. This -2 on the outside is going to be down 2. Oh, and then this, the 1/2, sorry, that 1/2, outside is going to be vertical, and outside is normal, so little means shrink, so it's going to be a vertical shrink of 1/2. Okay? Alright, describe this transformation, hit pause, come back when you're ready. Alright, so again, if you're describing the transformation, if you don't factor that out, you're not going to get the right shift. So if I factor out a 2, that's going to leave x minus 3/2, or 1.5, plus 5. So now I can do my descriptions. This is going to be a horizontal, you would think stretch since it's big, but it's going to be a shrink because it's with your crazy x of flip it over, which would be 1/2. This says go left 1.5, but it's with your crazy x, so that's going to be a horizontal move of right to the 1.5. And then the 5 on the end is going to be 5 units up. Okay? And there we go. Alright, so how do you perform multiple transformations on graphs of functions presented algebraically, graphically, and numerically? Well, whatever you're doing to x, you do in asymptotic order. And whatever you're doing to y, you do in PEMDAS order. That's algebraically. Okay? Alright, reflections. Reflections are when you can reflect over x. Okay? If you look at this red one and the blue one, if I turn the red one upside down, this would come down to here. And if I turn this section of the red one up, it would turn up here. Okay, so that's reflecting over x. Reflecting over y, if red is my original function, I would take this part and I would draw it on this side, and then I would take this part and draw it on that side. Okay, and then through the origin is a double. Alright, so it says find an equation. We're not graphing or anything, we're just finding the equation for the reflection across each axis. Okay, well if I'm reflecting across x, that means I'm multiplying the entire function by a negative. So I want to find a negative function, which means I take a negative times the whole function. Now, guys, be careful. When you distribute that negative, a lot of people think you have to distribute it to the top and to the bottom. No, 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 no. Pick one. Top or bottom, but not both. Okay? So if I go on top, that's going to be a negative 5x plus 9 over x squared plus 3. And that would be it. Alright, and if you look at the graph, there you go. Alright, so this, oh, I didn't do the other one, did I? Oh, I did it, split it up. Okay, same problem, but now we're going to reflect over y. If you're going to reflect over y, that means it happens inside, which means every x needs to change to a negative x. Alright, which means I would have 5 times negative x minus 9 over negative x squared plus 3. That's going to be negative 5x minus 9 over x squared plus 3. Okay, and that would flip it over. And I can support it graphically. Alright, so it says, let g of x be the reflection of f in the y-axis, which means they want to reflect it over y. If they want to reflect it over y, your negative has to go inside parentheses with your x. So, basically I'm changing all my x's to negative x's, which would give me negative 3x plus 2. Done. Let h of x be the reflection of that function in the x-axis. The x-axis, you multiply the whole function by a negative, distribute that, and you get negative 3x minus 2. There would be a reflection over the x-axis. Oops, you can see here that I typed them in, type this, and I type the original function, and did it reflect over y? So it goes this one. Oh, it's just a line. Never mind, Camden. There's your first line. And then if you reflect that, this section reflects down. Looks like you made two B's, but you didn't. You only made two lines. Same with this one. Okay. Alright. Go. Find the function rule if you reflect over y. Hit pause. Come back when you're ready. Good. Alright, so we are going over the y-axis, which means we need to make all of our x's negative. So I got 6 times negative x plus 9, which gives me negative 6x plus 9. Yep. Okay, you try this one. They want you to reflect over the x-axis. Hit pause. Come back when you're ready. And hopefully you got one. If they want me to reflect over the x-axis, that means the whole function gets multiplied by a negative. So I would have negative x squared plus 5, which gives me negative x squared minus 5. Yeah? Alright, there's the graph to back it up. So how is the graph of an even function affected by the reflection across the x-axis and across the y-axis? I don't know. I mean, I do, but you're supposed to figure it out. Find an even function, like the absolute value function. Okay, and if you reflect this across the x-axis, what's going to happen? How is the graph of an odd function affected by reflection across the x-axis and across the y-axis? So, same type of deal. Come up with where it is and describe it. Alright, so we're at homework. Happy homeworking, and I will see you next time.